All right, so here, 1.7 part 1 combination of functions, March 15th. Here we have a table of x and y values. We have two different y values, f of x and g of x. And you're asked to graph the following, so that's not going to be hard, right? And let's color code. So let's do f of x in red. Let's do g of x in blue. So we'll start with f of x. You have -6, 2, right? That's easy. Which is your label, geesh. So that's, let me do little tick marks here. That's frustrating. Let me do this in black. You can tell I did not make these notes. I would actually have these labeled. So 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay. So red, -6, 2 is right here. Much better when you have the tick mark. 0, 4 is right there. 5, 1 is right here. And 7, 1 is right there. Now in blue, or light blue, you're going to have -6, -4, way down here. 0, -3, way down here. 5, -1, way down here. And 7, -7, way down. Ooh, boy. Goes down here. Okay. Now, if you're adding f of x with g of x, you're simply adding the y coordinates. So I'll do this in green. -2. 1, 0, and -6. And if you're plotting that, we'll plot that in green. You do -6, -2. 0, 1, 5, 0, and 7, -6. So you can see that the green dots are all in between the blue and red dots, as they should be, because you're adding. Well, you had some negatives and positives. So, but yeah, that's just plotting points, not that hard. And then we'll go say orange here for the subtraction. 2 minus -4 is 6. 4 minus -3 is 7. 1 minus -1 is 2. 1 minus -7 is 8. So I'm plotting -6, 6, 0, 7, right there. 5, 2, right here, and finally 7, 8. Whoa, way up here. So yeah, that's all. Domain, you just give the x coordinates. So like obviously the domain is gonna be the same for everything. And usually we'll put like these in braces. I'll just go black. So you kind of just write that like -6, 0, 5, 7. The range, of course, would be 2, 4, 1, 1 for f. For g, I'll put little double quotation marks because it's the same as before. But range, of course, is -4, -3, -1, and -7. And I don't want to move the screen, but f plus g, the range, will be -2, 1, 0, -6. F minus g, the range will be 6, 7, 2, 8. So there you go. Not that hard, right? Pretty straightforward. Go ahead.
Are those
Yeah.
brackets or parentheses?
They're actually neither. They're braces like this. On the keyboard, if you hit like shift bracket, it kind of, let me do this. It looks like this. It looks like that. It's like a fancier type of I don't know what you call it, but just a little fancier than a bracket or parentheses. So that's all. And honestly, it doesn't really matter if you did a bracket or parentheses because we're not doing intervals. We're just listing numbers. Usually the standard for mathematicians, because you're giving a set of numbers, they call them braces. So these are braces. If that makes sense. So
Mr. Yi,
that's totally trivial, just so you know. Yeah, go ahead.
do you connect the dots?
No, we don't, because they're just they're not really just points. They're not equations or anything. I mean, if you want, go ahead. But no, we don't. Really, the whole point of this exercise was just to show that when you're adding or subtracting fractions, how that could change the range. It was actually kind of a pretty easy. Don't overcomplicate it. In fact, I don't think I'll even assess that. This is the page I care more about. I care a lot about this page. Here you want to find a domain algebraically, and you have to look for restrictions, right? This is so key. Look for restrictions. Restrictions, you're going to look for denominators and square roots. Those are the two things we're looking out for. Denominators and square roots. So do you see a square for A? Yes. X minus 3 can't be negative. So x minus 3 must be greater than or equal to 0. Therefore, x is greater than or equal to 3. How do I write that interval notation? Bracket 3 infinity. So that's part A. Any question about part A? Does that make sense, guys? We're good? Okay. That was a restriction because you can't square root negative numbers. Now let's look at B. Let's color for a bit of contrast. That's the denominator. X plus 2 cannot equal 0. So you set it equal to 0 and solve. So you're going to say, so it's all real numbers but negative 2. So in interval notation, you're going to write it like this. Negative infinity to negative 2, parentheses, union, negative 2, infinity. Therefore, negative 2 gets skipped over, which we want. So the solution for part A was this. The solution for part B was this. And both of them had restrictions, but different restrictions. Part A had a radical, more specifically a square root. Cube root, you've been fine. You can cube root negatives or odd root negatives. Even root, that's an issue. You can't even root negatives, otherwise it would not be real. So you have to make sure the expression underneath the radical is positive or 0. For denominators, the bottom cannot be 0. So set it equals 0, see what happens, and exclude it from your domain. So you exclude negative 2 from part B from your domain because we can't divide by 0, and negative 2 would make the bottom 0. For part A, again, you got to make sure we stay positive. 3 is okay. Anything bigger than 3 is okay. Anything less than 3 is not okay. So that's why we have the domain go from 3 to infinity, 3 being inclusive. Questions about parts A and B? And you have this recording to always kind of fall back on if you ever forget. All right, let's keep on moving. Let's keep trucking here. C is going to be all real numbers. There are no restrictions. Because that's just a quadratic function. That's like a parabola. When I say no restrictions, radicals or 1 over something on the bottom, right? We don't have that. But do you have a fraction for D? Yep. So we'll factor the bottom if it is factorable. And I will tell you, I will make it factorable because I want you to tell me what is not included. So x cannot equal 3, nor x cannot equal negative 1. So you're going to say this. And make sure you go in numerical order. So there you go for that one. Go and try E and F. I'll give you guys a moment to think those through, then we'll move on to the next page. Okay. So for E, you have a radical, right? We know that has to stay positive, so that has to be greater than or equal to 0. 3x is greater than or equal to -12. X is greater than or equal to -4. And it's included, obviously, because you can have 0 in the radical, unless it's at the bottom of a fraction, which we'll see in the next problem. So there you go. Now for this one here, again, 14 minus 2x must be, well, it can't be 0. So you're not going to do greater than, because it's in the bottom. But here, OK to equals 0, no denominator, just so you know. So 14 minus 2x is bigger than 0. -2x is greater than -14. You divide by -2, x has to be less than 7.
Wait, why did the sign change?
Great question. I just glossed over that. let's talk about it. I'm so glad you brought that up, because it's something that people kind of memorize and don't understand, and you want to know why. I love that. It's perfect. Thank you, Sharp Fast Math. What if I subtracted 14? Oh, sorry. Let me take it back. What if I added 2x first, both sides?
The sign would stay the same, right? Because it only flips when you divide.
Yeah, exactly. So here you get x is less than 7. What if I did it the way I just did it about a minute ago?
Then you'd flip the sign when you
Yeah,
divide.
'cause you want to guarantee the same result. Exactly right. Yes. You want to guarantee the same result, x less than 7, x less than 7. That's why we flip when we divide by a negative, is you want to guarantee the same result as if you didn't, as if you put x on the other side. So you want to guarantee that if you kept x where it was, but had a negative coefficient and divide by that negative coefficient, that you would get the same result if you move that variable to the other side to make it a positive coefficient and then divide it afterwards. It's kind of like if you, you could take 101 or 280. 280 might be a little easier to get to San Francisco than 101. So you want to get to San Francisco, you can take 101 and 280, but both freeways take you to the same place, right? They take you to the same destination, but you take either path. I would say the bottom one's probably more preferable because it's fewer steps, right? You just subtract 14 divided by -2. Here you had to add 2x, then divide by 2. I don't know, maybe it's about the same amount of steps, who knows? But you have to guarantee the same result. So anyway, that's why we flip when you divide by a negative. Because if you solve it another way, you still want to get the same, you still want the same result. The top doesn't matter, obviously top could be 0, who cares? 0 divided by anything is 0. So anyway, x is less than 7. So you're in interval notation, you're gonna write like this. -infinity to 7, and 7 is non-inclusive because we can't divide by 0. So that is the parentheses around 7. Okay, good. I'm glad we got that out of the way. And I know that this is covered in Algebra 2 because I did cover that with my Algebra 2 students this year or recently. So, okay, so let's talk about domain for a combination of functions. So f of x is just a line, right? That's just a line. G of x is just a parabola, right? I can't write parabola. So anyway, domains, all real numbers here. Likewise for parabola. But add the two functions, I mean, I just get x squared plus 3x minus 3, right? Or if I subtract the two functions, I'm doing 2x plus 1 minus x squared plus x minus 2, which would be negative x squared plus x plus 3, I think. Either way, my domain is going to be all real. And you combine those two. So when you ask to find the respective domains, you focus on the final answer. But must still consider prior steps. So if there was a domain restriction earlier on, you have to consider that also. But usually you tend to focus on the final answer and see, okay, well, here's the final answer. That's still quadratic. Yeah, all real, right? If you multiply the two functions, okay, it's fine. Let's do that. Before I do that, any question about parts A and B, though? Again, f of x, g of x, those are both domains of all real numbers. If you add the two or subtract the two, you still get all real numbers because you still get a quadratic function. Nope. Okay. So what if we let me zoom out. I could leave like that. That's fine. So if you multiply the two, you're doing 2x minus 1 times x squared plus x minus 2. You could FOIL it or expand it. I know you guys can do that. I'm not going to waste your time with that. But a domain is going to be all real again. To me, you don't really need to bother foiling. I mean, you're going to get something with like 2x cubed and a bunch of other junk. Again, I don't really care if you combine it. I mean, just the bottom line is that no, it's still going to be all real because that's just a polynomial, right? That's just a polynomial function, which always has domain of all real numbers. Now, this one's going to be interesting, though. F of x against 2x minus 1, the bottom is going to be x squared plus x minus 2. Now, the bottom does have x in it. The bottom cannot equal 0, right? That cannot equal 0. So if I were to factor it, I get x plus 2x minus 1. So x cannot equal -2, nor could x equal 1. Those are not okay. That cannot happen. X cannot equal -2, nor could x equal 1. Okay. So when you say the domain, you say -infinity to -2, union -2 to 1, union 1 to infinity. So that's your domain for that one. So that combination did have a restriction, even though individually f of x and g of x were all real. But when you divided, there became a restriction because you had a denominator with x in it. So sometimes the combination of functions, even though individually they could be a certain domain, the combination could be different for the domain because of having something in the bottom of a fraction. So the bottom line here is that actually, I'm not really sure what's going on with this, but if you see this here, like, you know, f plus g in parentheses, we just know that it means this. F minus g in parentheses, just know it means this. If you see FG combined in parentheses being multiplied, it's just this. If you see this right here, it just means F and G divided separately. So domain, I'm not sure what was really meant to be put in this box here, to be honest with you, but I would just say consider individual domains in domain of combination. So I would just say, you need to consider that. Questions? Okay, so that's yeah, I'm not gonna do part 2. I'm gonna say part 2 for Friday. Actually, I think what I might do, I might make it part of a homework assignment. Because I'm not assigning any other. Well, there is other homework that is assigned, but I'm gonna do a video of part 2 later today and then post that to Schoology. I don't want to fall behind because actually 1.8 I might need all Friday for that. But I'm not gonna do part 2 during the Zoom call because that'll just take too long. But let's finish off this page and then we can do the homework quiz, and then we can end our call. Okay. So here we have 2 radicals. So those are going to have restrictions each. So for f of x, obviously x has to be bigger than or equal to 0. For g of x, of course, 4 minus x has to be bigger than or equal to 0. Or in interval notation, bracket 0 infinity. Here, divided by -1. So we negative infinity to 4 brackets. So here you have to evaluate, find the following functions and evaluate. Okay, got it. So obviously you're adding these 2 radicals together. And when you plug in 3, I mean, you just have this, so that's not hard. Or for f of g of x, you're doing root x over root 4 minus x. If you plug in 0, you have root 0 or root 4, 0 over 2, which of course is 2. Sorry, 0. Can't believe I said that. There we go. Now the domain's interesting. What you'll have to do is be as restrictive as possible. So here I know that x is bigger than 0, right? Here I know x has to be less than or equal to 4. So you have to make sure you make both happy. That's why you have to be as restrictive as possible. You have to make both happy. Make both radical expressions happy. So you gotta be bigger than 0, but less than 4. So domain's gonna be this. Anything between 0 and 4. You can't go bigger than 4 because then this one won't be happy. You can't go less than 0, this one won't be happy. So you have to combine it. So there's not really a hard and fast rule for finding the domains. You have to kind of take each situation. Each situation is kind of unique and kind of just consider each one for its uniqueness and use some logic. So these are a little tricky, but you do have to be mindful about everything that's going on. That's why I say be as restrictive as possible. Make both radical expressions happy. Like for C, again, you can't be less than 0. You can't be greater than 4, but you can't equal 4 either. So in this case, you go parentheses. So you still can't radical negatives in either one, right? Or square root negatives in either one, but you can't include 4 because then you're dividing by 0. Four can't be included. Because then you're dividing by 0. And then if I reversed it, so you have root 4 minus x over root x. So it's root of 4 minus 2 over root 2, which is root 2 over root 2, which of course is 1. Now, again, you can't be greater than 4. Can't be less than 0, but you're not going to include 0. You include 4, but you can't include 0 because you can't divide by 0. So that's kind of what's going on with that one too. Okay. So this is part 1. I think this is intended to be over 2 days. So yeah, because I think it's a little much, and you guys have other things you got to do. So I don't want to overwhelm with too much stuff. But just so you know, the second part is going to involve putting a function into a function, which you guys have seen before. So it should be review. And I think there was what 3. Yeah, I can make it probably a 10 to 15 minute video on this once we sign off. So that'll be part of homework. I'll update the homework. Let me stop the recording. Let's talk about